Calculus is about analyzing functions based on their rate of change. Now remember that rate of change is basically the same thing as slope. If I have a straight line with a certain slope, then its rate of change is y units of change for a given number of x units, and that y over x gives us the slope. For a straight line, that slope is the same everywhere on the line, but for a curved function, it's changing all the time. If I take a line, this blue line right here, and put it tangent to the curve, sort of like putting a tangent line to a circle, I can see that it's touching at one point and that its slope is matching the rate of change of that function right at that point. If I move the tangent line around, then the slope changes as the curvature of the function changes. In other words, the direction that the function is heading is changing at every single point. The slope of the tangent line tracks that. And so if I go back over to this point here, I can see that my green function graph is increasing, and that corresponds to having a positive slope for the tangent line. Every place the graph is increasing, I have a positive slope. As the graph curves down, my slope decreases. So that's another thing that the slope of the tangent line can tell me, is the direction of curvature of the graph. When I get up to this maximum point right here, my tangent line is horizontal. It has a zero slope because the graph in green is neither increasing nor decreasing. That same thing happens down here at a minimum point. So finding a zero slope for the tangent line is important for trying to find maximum and minimum points on my function. And this section of the curve here, you can see that the blue tangent line has a negative slope, indicating that the graph is decreasing. And so we want to be able to calculate the slope of the tangent line, which is going to give us the value of a function's rate of change at any point. Now let's put this together and see if we can figure out how this is going to work. So I have the same green graph, just shown in 3D here. I have my blue tangent line through the point, and you'll notice that there's a blue graph down below. This graph is plotting the values of the slope of the tangent line, and that graph, the blue graph, is called the derivative. It's the slope function of the green function. So as I move around, you can see that the value of the slope of the tangent line is equal to the value of the blue function. In other words, the slope of the blue tangent line has the same value as the length of that blue arrow that's indicating the y value of that derivative function. Right here, where I had my maximum point, you can see that the blue function is 0. The blue function has negative value during the time where the green function is decreasing. At my minimum point here, I'm back to 0 on my blue function, and so forth. Now, if I look at the blue function, I see some area shaded underneath the graph of the blue function. And what that is telling me is how much of the green function I have. In other words, if I back up this edge of the area and go all the way back to the beginning, right here, my A and my B values are the same, and you can see I have no green function. Okay, so there's no value to the green function because I'm starting and stopping in the exact same place. If I start moving my B values so that I'm accumulating this area, the amount of area shaded in green is the same as the length of that blue arrow, or that green arrow rather. And that green arrow is telling me how much change I have in my green function from that point A to wherever B is. So as I move B along, the amount is increasing and decreasing, but it's equal to the accumulated amount of area under the graph of B. And so these connections, the tangent line giving us the rate of change and the area under the rate of change giving us the original function, are the things we'll be studying in calculus class.